Alrighty, class. I am going to go ahead and do this is 2.2 for adding radicals. But before we go to that, again, there are some terminologies, or maybe just one word that you need to remember, and that is the word like terms. So what are like terms? Okay, like terms could be numbers. They could be algebraic expressions like 2x, 5x squares, things like that. But the one thing that you need to keep in mind is, in order for two terms to be like terms, they have to have the same variables with the same exponents. Okay, so same variable with the same exponents. So here I have put a few here for you, and we are going to identify the like terms. Okay, so here is number one. Here you have 5 plus x minus 8. Which of these, by the way, this problem has three terms. Okay, you have positive 5, you have plus x, and you have negative 8. So there are three different terms, in case you don't know what I mean by terms. Okay, that's a 5, and then there is the positive x, and then there is the minus 8. So it's three terms. Now, which of these are like terms? The like terms are, again, they can be numbers, or they can be algebraic expressions that have the same variables with the same exponents. Okay, so here I have the 5 and the minus 8. They are like terms. They are numbers, so I can add them. You know that. Okay, so but here we don't need to add them. We just need to identify. So all I'm going to do is I'm just going to quickly erase that, and I'm just going to identify them. I'm just going to underline them. Those are my two like terms. Okay, and if they ask me to simplify the problem, that I know that I can add the 5 and the negative 8 to make it look easier or smaller. Okay, number two, I have four terms. Okay, so the terms is 4y negative 7x positive 6y and positive 1x. Those are four terms. Okay, so which two are alike? Again, I'm going to quickly erase them, and I'm going to identify them. Okay, so I have my y's, y to the first power, y to the first power. These are like terms. Also, the negative 7x and the positive 1x are like terms. Okay, so I circled the x terms, and I underlined the y terms. Now, it's important for you to know like terms, because in math there are many things that are like terms. You may have heard about that, you may not. So I know 1 and 2 you have seen in Algebra 1, and in advanced algebra class you would also be able to identify radicals that like terms also, or you may not. But if you haven't, here is how we identify like terms with radicals. Okay, so radicals are like terms if the radicand have the same expression, if they have the same, well, basically, if the radicand are the same. Okay, so remember, the coefficient is the number outside, and the radicand is the number inside the radical. So you're just looking for the inside number. Okay, so here we have three terms: 2 radical 3, 1 radical 3, 1 radical 2. Again, we don't write the 1, but it's there. Okay, all right, so what are the like terms? Okay, so look at the radicand. This is a 3. This is a 3. They are the same. So therefore, 2 radical 3 and 1 radical 3 are like terms. You can add them if you want, okay? But we don't need to, because that's not the focus of this problem. We just need to identify. That third term has a 2. That's different from a 3. So that's why it's not underlined. It's different. It's it's just like y, okay? So you could have 2x plus 1x plus y. Same thing, okay? But instead of x and y, you have the radical 3 and the radical 2. All right, same thing with this number 4. Okay, so again, I'm going to check the radicand. Okay, so here I have a 31. I have a 31 down here. So those two are like terms. It doesn't matter what the coefficient is. Okay, just check the radicand. And of course, the middle term has a 5, so we know it's not like any other radicand that you see out there. So therefore, your two like terms are 4 radical 31 and negative 2 radical 31. Okay, so with this worksheet, what we are going to do is we are going to identify like terms, and we're going to add them, okay, or combine them. All right, so that takes us to our problems. But before we go to the problem, there are some review questions here. Okay, So I'm going to go ahead and do this problem, okay? So let's do, I think you will ask me about this one. So let me quickly do this one for you. We're working with the fifth root, okay? Fifth root means look for 5 of a kind, okay? So the coefficient is negative 3. I'm just going to write it down. And I want to break down my negative 96. Okay, this is a special problem because the radicand is negative and the index is 5 with the negative. So that's something that that's a special problem, okay? Because anytime you have a negative in the radicand and or the radicand is negative and your index is 5, you can take a negative 1 out right away, okay? So it's just like negative 1 times negative 1 times negative 1 times negative 1 times negative 1 5 times 96. Okay, so you know right away that you have 5 of a kind and you can take one of those out. Okay, so if you take a negative 1 out, you will have a negative 3 times a negative 1. Notice I put them in parentheses. And then you have the fifth root of 96. And I made a mistake here. I forgot to write my index. I gotta write it down. Okay. So all of a sudden my problem becomes 3. And then I still need to break down that 96 so I can see if I can simplify it further, okay? All right, so I just took care of the negative sign. That's what you do every time your index is a odd number and you have a negative sign in for your radicand. All right, 96. How do we break down 96? Easiest way is divided by 2. So if I divide 96 by 2, what do I get? I will get a 48 times 2, okay? That's 96. And I know that 48 is 6 times 8, okay? So I'm going to do a little bit of mental math here, okay? So first of all, break down the 6, okay? So 6 is 2 times 3. And 8 is 4 times 2, so that's 2 times 2, that's 4. And then another 2 for 8, okay? So far I have 6 times 8, and then I have my other 2 here. Don't forget that 2, okay? So there's a lot of 2 here. Maybe for this problem, for some of you, you might just want to break down everything, okay? I just decided to do mental math because many of you are able to do that, and anytime you can, that will speed up the problem. All right, so we're looking for 5 of the same kind, okay? Let's see if we have it. I have 2 there, 1 here, 1 here, 1 here, and 1 there. So I do have 5 2s. That means I can take out that 2, okay? And once I take it outside the radical, it's gone, okay? So I'm going to take it outside the radical. So I have a 3 times a 2, okay? So I'm going to cross this out so I don't count it in my last final part of my answer. I still have my fifth root, and I have a 3 inside. Final answer for the problem, 3 times 2 is 6, and I have my fifth root of 3. Check your answer, please, okay? Again, not all problems is this difficult. If you can do the other problem, you should be okay. If when you're on an A, then you need to be able to understand number 1, okay? All right, so that's just a quick review on a very difficult problem, but everything else is pretty straightforward. So I am going to go ahead to new stuff, okay? How do you add radicals? So make sure that the radicand are the same, okay? So check the radicand, okay? I would just check them. They are the same. That means you can add or subtract the coefficient, okay? Depending on their sign, okay? You can combine them. Okay, I have a 2 minus 2. That's a 0. 0 times radical 5 is 0, okay? So that's 0 times radical 5 is 0. So your answer is 0. Don't write down 0 radical 5, okay? So that's for number 5. If you go to number 8, your radicand are the same. That means these are like terms. What can you do to the coefficient? You can add them. Negative 2 added to negative 2 is negative 4. And then don't forget to write down the radicand. The radical term, okay? So square root of 3. This is your answer for number 8. Again, check your answers, okay? Okay, let me see. Oh, number 9. Take a look at number 9. We have a problem. If you check, that's a 6, and that is a 24. What does that tell you? Maybe you need to break down the 24, simplify it, and see if you do have like terms, okay? Because the first term you can't do anything, because when you break it down, guess what you have? You have a radical. You have a radical 3 times 6. I mean, not 3 times 6, 3 times 2. And you can't take anything out because you don't have a pair, okay? So you don't need to break down that one. But let's break down the 24 and see if we need to simplify it, okay? All right, so you should always check it. So 24 is 6 times 4. So I'm going to go and break down the 6. That's a 2 times 3. And the 4 is a 2 times 2. And we're working with the second root. So I do see that I have one pair of 2's, which I can take outside, okay? So right now, this is a 1, okay? So I have a 1 times 2. For that pair, it's gone, and now I have a 6. All right, so that's what it is, okay? So radical 24 all of a sudden transforms into 2 radical 6, and we still have that 1 radical 6. Okay, so I'm just going to get 1 radical 6 because I want you to see that now you have the same radicand. So these are like terms, and now you can go ahead and add 1 and 2. So your answer would be 3 radical 6 for the answer. Again, check your answers, okay? Okay, I'm going to do one more and leave you alone, okay? Oh, look at this one. Number 13. Beautiful. Here you have 27 and 27. It's like terms. There is a 1 here and a 1 there. Go ahead and add them right away. 1 plus 1 is 2. Radical 27. Now, if you go and check your answer for 13, and you wouldn't know, but unless you check, it says that the answer should be 6 radical 3. So where do we go wrong? Let's go back. Okay, so if you check the answer and it's not the same, then you know that there's something else you have to do. So maybe you need to break down the 27, okay? So let's break it down. We know that 27 is 9 times 3. And we know that 9 is 3 times 3. And we need another 3 for that third factor, okay? So now you see that you do have a pair of 3 that you can take one of them out, okay? So 2 times 3 and then radical 3, okay? That would give you the answer, which is posted in the back. This is why it is very important for you not only to do the work, but to also check your answer to every single problem. That's what a good student does, all right? So this is 2.2, how do you add radicals? All right, I'll stop here. If you have any more questions, you can certainly send me an email, or we will see each other during Google Meet, okay? Bye-bye.